and water, juices. So they all are matter. Anything that can occupy space, that can have space, is called matter. What matter cannot be? An affection. Like, for example, happiness, sadness. Okay, that is not matter. We can feel that one also. We can feel the happiness. We can feel the sadness. We can feel the air, the cold air, the hot air. Okay, we can feel that one also. But air occupy the space. Okay, we can compress it. We can fill the air in the cylinder, but we cannot fill the happiness in the cylinder. Happiness does not. We can feel that one. Okay, so we will simply say that anything that occupies space and has mass is called matter. Okay, understood? Understood?
Sir.
So matter, we have divided the matter into broadly three categories. In this chapter, we're going to study the solid state, the physical state, and the solid state, liquid state, and the gaseous state. Okay, like the solid state, liquid state, and the gaseous states. As you know that matter on the basis of their, like example, for example, if you see anything around you, you will see either it can be a solid, it can be a liquid, or a gas. Okay, it can be a solid, liquid, or a gas. So same thing, we can divide the same metal on different basis also. Like, for example, if I ask you to classify the cars around you, so what you will say? You will ask me the basis, sir, on what basis you want to classify all the cars. Do you want to classify them on the basis of uh, simply on the basis of the fuel that you use? Either the petrol car will comes in one category, the diesel car will come under one category, okay, or the CNG or LPG car will comes under one category, or the brand. You can divide the same cars on the brand, like Mercedes comes under one category, okay, or Maruti Suzuki will come under one category, Toyota will come under one category. So same matter that we see around you, we can divide into solid, liquid, and gas, and the same metal we can divide into pure and impure substance, pure and impure, and that you will going to study what is pure substance and impure substance in the next class. Got it? Got it? So please note it down. Note it down. What is matter? Write down the chapter name first. Okay. Matters in our surrounding.
Uh, could you read after space, like anything that?
Your voice is not audible. Please come closer to the mic.
Hello.
Yeah, speak.
Yeah. Could you read the answer uh of the question? What is
Yeah,
matter?
here it is. Anything that occupies space and
Ah,
has mass is called matter.
oh, mass. Okay, thank you. Can you scroll it a little down?
Yes. Don't write it. We will study in this chapter. Or you can write it. Write it. Exactly same. The chemical combinations, on the basis of their chemical combinations, means we can divide the matter into two broad categories: physical state and the chemical, on the basis of physical state and the chemical combination, that elements and compounds. Plasma and Bose-Einstein condensate are the other states of matter that are found in stars. Plasma is found in stars. Okay. So this is another state of matter. You noted?
Just 1 second. After you wrote plasma, can you read the second thing?
Bose-Einstein condensate. B-O-S-E, Bose. Einstein.
Could you repeat the spelling?
Done?
Should I write the characteristic of particle?
Yeah, first let me explain you.
Oh,
So what is the characteristics? So characteristics, can you tell me that what do you mean by the word characteristics? Characteristics means that something have some specialized property. Like for example, if I ask you that what is the difference between a book? For example, if I close your eyes with a bend, black bend, okay, and ask you to and give you a book. And another thing, I give you a something like plate. You will be able to recognize that one easily, that it is a plate on which you eat food, and that one is book, because book have some characteristic that it has a pages, it can be easily fold, okay, like this. And plate is just like metal plate, okay. So or a desktop or a laptop, if I you can easily feel that it is a laptop, it is a keyboard, okay. So why the characteristic? Because your brain is fed with the characteristics of those substances. Like a laptop must have a screen, a keyboard must have so many numbers, okay. so many keys. Same thing, the characteristic, that what is the characteristic? Like for example, what are the characteristics for a human beings? That they have two eyes, one nose, and a small mouth on the face. Okay, and two hands having five fingers. Okay, so these are the characteristics for human beings. Okay, same thing. What is the characteristics for a solid state? Is I'm audible?
Sorry, you got stuck in the middle.
Yeah, but my voice is clearly audible, na?
Yeah, now it's audible.
Sometimes the internet connection is easy. Okay, what is saying here is that particles of matters have space between them. First property is that the particles of matters have space between them. Space, like for example, if you just simply have this figure in which these are the water particles and you add some sugar solution to it. Okay, sugar to it. So according to you, when you are adding something, the level of the water should rises. Hmm? Like for example, you have this one, you mark the level here. Okay, then you add some sugar to it. Then what would happen? Can you tell me? If you are not going to dissolve and you add sugar to it, the sugar will remain here and will rise the level of the water. But when you dissolve it, the level of the water remain same as it is, as the previous one. So why it is having the same level? Where does the particle goes? When you are dissolving sugar, you take a glass, okay, and add some water to it. Then you have 2 or 3 tablespoon sugar to it, and now you will see that slightly the level of the water will rises up because you have added. But when you dissolve that sugar, then the level of the water will drop again and reaches to its original level when no sugar was added. Are you getting my point? So simple हम बोलेंगे कि निशा, are you comfortable, means can you means will you be able to understand betterly in English or Hindi? Should I explain you? Is it okay? Okay in English? Okay. So when the water of the means simply the level of the water will rises means reaches to its original level, and simply we'll say that the particle of the sugar goes in the uh, space between the water. Okay, got it? Got it? So please note it down. Characteristics of particle of matter, and draw this diagram. You noted? Noted, beta?
1 minute.
Okay, noted fast. Done.
Please scroll a little down.
Okay.
That's it.
Finish. Okay. Just a minute. So the next characteristics or next property, what is the next property? The particles of metals have a space between them. So when you are dissolving something, okay, in water, then they if get it dissolved, it goes into the intermolecular space of the water. Okay, it goes into the intermolecular space of the water, and as a result of which, we will simply say here that the particles of water have a space between them, and in that space, the sugar particle goes. Got it? Can you guess one thing, that why the sugar crystal is big enough, then how it goes into that space? If you look into the water, there is no space available. Then how does it goes? How does it goes? Can you tell me? Can you tell me that how does it goes into that space?
It's like water particles, how like they're not congested together like as much as solids, and then they do have some space in between. So like
No,
the
I'm saying simply, I'm saying, yeah, you are correct. I'm saying simply that this is the particles of sugar. Okay, this is big enough that you can see it with your naked eyes. And when you see a glass of water, there is no space available in that one. You see everywhere water particles. Then how does it goes?
I
Then
don't
how
know.
does it goes into that? Can you guess? Any
Um,
idea? Hmm? So simply we will say here one thing, that uh, oh, my camera is not. We will say one thing here, that the particles, there are millions of particles are present here. Okay, there are millions of, means one crystal is made up of millions of particles. Millions of particles are there. So when we dissolve it into this one, it slightly get disrupted and get detached. Okay, are you getting my point? Getting my point, Nisha? What I'm saying?
so
I'm saying simply that this crystal of sugar is made up of millions of small sugar particles. One crystal. So when we dissolve in it, then this crystal break and into millions of particles, and that particle goes into that space. Like for example, this is a particle of sugar, and it is made up of millions of particles. So when you dissolve it, when you stir it with that one, then it goes everywhere. Got it? Got it? Next property is that particles of matters are continuously moving. Can you guess what is that property, that particles of matters are continuously moving? How can you say that particles of matters are continuously moving?
could you repeat?
I'm saying that how can you say that the particles of matters are continuously moving? How can you say this one?
Uh,
That the particles of matters are continuously moving. Moving. Like for example, if you are sitting in a room.
it's because we can tell by air. It's because like if we spray a perfume, if a person is like far away, they like smell it. It's because the particles in the air are still moving.
Yeah, yeah. So same thing happens here also, that the particles of matters, if I'm talking about the particles of matter, so particles of matters are continuously moving, and this can be easily explained by a very simple example. That for example, if you burn an incense stick means agarbatti, okay, then you will feel that everywhere you can easily smell. Okay, like for example, if your mother is cooking food in the kitchen, okay, so if she is cooking food in the kitchen, then what would happen? If the cooking of the smell of the cooking food will reaches everywhere.
Yes.
Hmm? It will reaches everywhere, and you can easily smell that one. Or for example, if you have a beaker of water, and if you add a color to it, color, uh, a solid color particles like potassium permanganate, which is a group of particles. So when you drop it in the corner, you will find that the whole water after some time, initially it was not. It was when you thrown it into the corner, it will settle down. But after some time, you will find that the whole water will become purple, because slowly the particles of this one will start scattering everywhere, and you will feel that it will scatter everywhere. And when it is going to scatter everywhere, then simply we'll say that the particles of matters are continuously moving, because it make the whole water. The smell of the cooking food, the whole water become purple. Okay, and the spray, you see, you give a very good example. Okay, these all are the examples where we'll simply say that the particles of matters are continuously moving. Okay, got it, Nisha? So please note it down, this one. Particles of matters are continuously moving. Note it down. You done, Nisha?
Just 1 minute.
Okay, do it fast. Draw this one fast. Are you there?
Yes, sir.
You done?
No, just one. Oh,
Done, beta? Okay. So here the question is going to came that with the help of an example, if teacher asks you that Nisha, with the help of an example, explain that the particles of matters are continuously moving. So how will you explain this one? How will you explain? The particles of matters are continuously moving. How will you explain this one? Try to give me some words, whether it is correct or wrong. It's okay. How will you explain?
can I read your?
Huh?
Nothing. I I said like, can I read your?
Ah, okay, try it.
Smell
Okay,
of
try.
cooking food reaches to everywhere in the house because particles of matter are continuously moving.
Yeah, the particles of matters are continuously moving. The particles of matters are continuously moving can be explained by several examples. Okay. And when a drop of potassium permanganate is KMnO4. Okay. It is purple in color. It is purple in color. Okay. So when we'll simply say that if the particles of matters are continuously moving, this is only be proved when, like, for example, you add a potassium permanganate in the water. Instantly, the whole water will not turn purple. But if you keep the water for some time, then slowly, the particles of potassium permanganate will start dissolving and it will scatter everywhere. So this is the reason that why we say that particles of matters are continuously moving. So please note it down that how can you explain with the help of example, illustrate that particles of matters are continuously moving. Done, Nisha?
Just 1 minute.
Done?
Done, sir.
Very good, beta. Very good. The questions, a very important question that you have to memorize it right now, okay? A very important question on this property that the particles of metals are continuously moving. It comes in your examination. And what is that? The question will come that the smell. For example, if your mother is cooking food, okay? And the smell of that cooking food, that hot cooking food will reaches everywhere. But for example, if your mother kept a food which is not just cooked, cooked it yesterday, and she last night she put that food in the refrigerator, and now today she take it out. Like for example, your mother cooked some food yesterday. During the night hours, she took the remaining food and kept it in the refrigerator, and then on the next day, on early morning, she kept it on the table. You will feel that the smell of that cooking food or that food that is kept out from the refrigerator will not reaches everywhere. But during that time when your mother was cooking, it will reaches everywhere. Can you guess why it is so? Why the smell of the cold food is not reaching at faster rate? Can you guess? So this is very simple. Just the particles are feeling cold. They are kept in the refrigerator. They are like, no, 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 I will not give. They are feeling colder. So, like the person in the cold, they don't want to come out of their blanket. The same, the particles are feeling cold. So they are kinetic. Cold means the kinetic energy of the particles are less. Hot means the kinetic energy of the particles are more. So when there is hot, the particles will travel the faster rate. Okay. And when they are cold, the temperature is low, the kinetic energy is low, and they will not travel at faster rate. So the smell will not reach us everywhere. You understood?
Sir.
Understood? So please note it down that why does the smell of the cooking food reaches everywhere in the house, but the smell of the food kept outside the refrigerator, cold food do not. Because the cooking food is hot and its particles have high kinetic energy. Than the cold food kept in the refrigerator. Hence, due to low kinetic energy of cold food particle, they will not travel larger distance as compared to the particles of cooking food. Done?
Just 1 minute.
Mm.
That's it.
Done. Very good. Very good. I'm proud of you. Next is particles. Okay, just try to memorize this one. Okay, try to memorize these questions. This is very, and the next part we'll learn in the next class. Just try to memorize this one. Let me
I
check how much.
then I read it once.
What are you saying?
After I finished writing this question, I read it once.
This one, na?
Yeah.
Okay, you can memorize it. You can read it multiple times. Try to memorize it. याद करने की कोशिश करो और मुझे सुनाओ.
Done, sir.
Wow, proud of you, clapping for you भाई. इतनी जल्दी याद हो गया? चलो सुना.
Because particles of cooking food are hot, it has higher kinetic energy and compare to the comparison of cold food kept in the refrigerator. Hence, due to low kinetic energy, it does not travel larger distances and in comparison to the cooked food.
Wow, shabash, clapping for you भाई. वाह,
Yeah.
shabash. Good. So rest of the portion will going to start in the next class, just because you were late, and please be on time for the next class. And secondly, there is an iftar timing, so otherwise